This is our week 10 review. We're looking at cumulative frequency, box plots, histograms, and circle theorems. Cumulative frequency. When we have cumulative frequency, we add up the frequency as we go. It's like a running total of frequencies. So we've got a frequency table here. So between 100, when it's the weights of some objects we're looking at, between 100 and 120 grams, there are 16 objects. Between 120 and 140 grams, there are 28 objects. So in a cumulative frequency column, I'm going to say there are 16 objects up to 120 grams. And then I'm going to add on 28. So 16 and 28 make 44. So there are 44 objects with a weight up to and including 140 grams. Then I'm going to add on the 32. So that makes 76. So 76 objects with a weight of 160 or less. Then the 15. So that makes 91. So there are 91 objects with a weight of 180 grams or less. And then the 9. So in total there are 100 objects, and they all have a weight of 200 grams or less. So I'm going to plot this on the graph. I'm going to plot 16 against 120. So it's always the top point. So cumulative frequency against the top point. So 120, 16. 140, 44. So there are 44 objects with a weight of 140 or less. 76, 160. So 160, 76. 180, 91. And 200, 100. And we join them up with a smooth curve. So use your graph to find an estimate for the median. There are 100 objects, so halfway the median is going to be 50. So we go from 50 on the frequency along to our line, and then down to the weight, and read off. I'm going to say it's 142. So 142 grams. If we were asked to find the quartiles, so for the lower quartile, we're looking at 1/4 of the data. So that would be the 25th. So we'll go from 25 to the graph and down. For the upper quartile, that would be 75. 3/4 of 100 is 75. So we'd go again to the graph and down. So that is our cumulative frequency. For box plots, we have lines drawn on the box plot for the lowest value, the highest value, the lower quartile, the median, and the upper quartile. So we've been given some information here. We've got the shortest plant and the tallest plant. So they both get a line on our box plot. So 10 centimeters for the shortest plant, 52 centimeters for the tallest. We've got the lower quartile at 24. And we've got the median as 35. But you can see we've been given the interquartile range. We haven't been given the upper quartile, so we can work it out. The lower quartile plus the interquartile range. The interquartile range is the difference between the upper quartile and the lower quartile. So if we do 24 plus 15, we can find the upper quartile, which is 39. So there are our 5 lines on the box plot. We join a box around the quartiles with the median inside it. So that represents the middle 50% of the data. And then we draw a line out to the highest value and a line to the lowest value. So that is a box plot. Question 2 is asking us to compare box plots. So we've got 2 different classes with test scores, and we need to compare the distributions of the scores. To do this, we compare the average and we compare the spread. So we look at the median for the average. So the median is lower for class A. So the median is lower for class A. We can say on average the score in class A was lower, and we can look at the spread, so either the range or the interquartile range, and we can see they're both lower for class B. So the interquartile range is lower for class B, and we can say that shows that there's a lower spread. The scores, so class B scores are less spread out. And that's what we have to do to compare box plots. So compare the average, compare the median, and compare either the interquartile range or the range for the spread. And now a histogram. So with a histogram, the frequency doesn't go up the y-axis. The frequency becomes the area. The frequency becomes the area, and the height we call frequency density. And frequency density can be calculated by doing frequency divided by the class width. So how wide the bar is. So the 0 to 10 minutes bar is going to be 10 wide. The difference between 0 and 10 is 10. So we're going to have 0, 10, 20, 30, 40, 50. And that will be our time in minutes. And then we're going to have frequency density. And we don't know the scale yet, so we're going to leave that for now. So the first bar has got an area of 6, a width of 10. So the frequency density is 6 over 10, which is 0.6. The second bar, the width is 10 again. 12 divided by 10 is 1.2. Then the 20 to 25 group is 5 wide. 16 over 5 is the same as 32 over 10, so 3.2. 25 to 30 is 5 wide again, so 22 over 5 is 44 over 10, so 4.4. And our last group, 30 to 50 minutes, is 20 wide. 8 over 20 is 4 over 10, which is 0.4. So the highest frequency density is 4.4. So we'll go 1, 2, 3, 4, 5. So now we just need to draw it on. So the 0 to 10 group has got a height of 0.6. So the 0 to 10 group has got a height of 0.6. 10 to 20 goes up 1.2. 20 to 25 goes up 3.2. 25 to 30 goes up 4.4. And 30 to 50 goes up 0.4. And that is our histogram. And circle theorems. I'm going to do 4 questions on circle theorems just so I cover as many as possible. Question 1, find the size of angle x. So we've got AB here, which is a tangent to the circle. AB is a tangent, and OB is a radius. So a tangent meets a radius at 90 degrees. So whenever a tangent meets a radius, we get a 90-degree angle. So tangent and radius are perpendicular lines. So now we can work out AOB. So AOB it's in a triangle with 90 and a 30. So 90 and 30 add up to 120. So 180 take away 120 is 60 degrees. So it must be 60 degrees because angles in a triangle add up to 180. Now there's 2 ways of working this out now. So we could do angles in a straight line, and then angles at the base of an isosceles triangle. Or we can say the angle at the center is twice the angle at the circumference. So x is going to be half of 60, which is 30 degrees. So x is 30 degrees because the angle at the center is twice the angle at the circumference. So we've got an angle at the center coming from the same points as the angle going to the circumference. If you'd worked it out with a straight line and an isosceles triangle, you would get the same answer. Question 2. Work out the size of angle x. So angle x, you can see we've got a cyclic quadrilateral, a 4-sided shape inside a circle. So the opposite angles in a cyclic quadrilateral, so the opposite angles in a cyclic quadrilateral, a 4-sided shape inside a circle, add to 180 degrees. So 180 take away 98 is 82. So x is 82 degrees. And find the size of angle y. So again, like the previous question, we can say the angle at the center is twice the angle at the circumference. So we've got our 82 and y, they come from the same points, they're in the same segment, so y is going to be 2 times 82, which is 164 degrees. So that's because the angle at the center is twice the angle at the circumference. Question 3. Write down the size of angle CBD. So CBD is this angle here. And this is the alternate segment theorem. So the alternate segment theorem. So this is when we get a triangle in a circle and a tangent. So the angle that the tangent makes with this chord here equals is equal to any angle that comes out of that chord in the alternate segment, so in the other direction. So angle CBD is 76 degrees because of the alternate segment theorem. The alternate segment theorem would also say that this angle, ABE, is equal to this angle here, DDE. The second question, find the size of angle ABE. So ABE, we can use angles in a straight line or angles in a triangle. So let's use angles in a straight line. So we've got 76 and 64, which add up to make 140. So 180 take away 140 is 40 degrees. So we could use the alternate segment theorem with angles in a triangle, or we could just use angles in a straight line. So it is angles on a straight line. Add to 180 degrees. And question 4, find the size of angle ABD. ABD, so that's this one here, and it's going to be equal to 64 because angles in the same segment are equal. You can see that these two angles come from the same points, so ABD and ACD, they're coming from the same points. We say they're in the same segment, so they're equal. So it's 64 because angles in the same segment are equal. Part B, find the size of angle ADB. So where's ADB? ADB, so this one here. And we've got an angle in a semicircle here. So BOD is the diameter. So BAD is an angle in a semicircle. So that's 90 degrees. So angle in semicircle is 90 degrees. So we've got 64 and 90. We're finding the missing angle in the triangle. So we've got 90 and 64. So what's missing? 90 minus 64. So if we take off 90, we've got 90 left. So 90 minus 64 is 26 degrees. So because angles in a triangle add up to 180, ADB must be 26 degrees. So that was our week 10 review. An assessment is now available. The link will be in the description or at the bottom of the page on the website.